Okay, let's work through OpenStax College Physics Example 1.1. Unit conversions, a short drive home. Suppose that you drive the 10 kilometers from your school to home in 20 minutes. Calculate your average speed. Then there's two parts, A in kilometers per hour, km divided by h, and B in meters per second. Note, average speed is distance traveled divided by time of travel. And so just to note here, this is actually an equation from chapter 2, which is equation 2.6, which is that v with a bar on the top, average speed, is equal to delta x divided by t. That's the typical notation you have there. So I do think it's always good to draw a quick little diagram. If this is your home and this is over here your school, then the distance, which I'm going to call delta x, is equal to 10.0 km. And so that's a known. And also that the time is equal to 20 minutes. So really this is just about keeping track of all the units. We have that average speed is equal to delta x divided by t. So in this case it's 10.0 km divided by 20.0 min. We want to multiply by a factor, some known factor of which equals 1, so that whatever's on the top has to equal whatever's on the bottom. And we want to purposefully make the minutes cancel out. So since minutes are on the bottom, I want those on the top. And I want it to be in kilometers per hour for question A. So I want hour here on the bottom, just h. And this way we know that minutes will cancel minutes. So how many minutes are there in 1 hour? Well, there's 60 minutes is the same as 1 hour. So what we do, and we're going to get kilometers per hour, is we're going to say 10.0 multiplied by 60, since that's on the top, divided by 20.0. And whatever all that is, that's going to be kilometers per hour will be the final units. So just bringing up a calculator here, I've got 10 multiplied by 60 divided by 20, and I get 30, which is actually a typical speed limit for a school zone, so seems okay. And for part B, they wanted you to do the exact same thing, except now they want the whole thing in meters per second. So we're going to have to convert to get away from kilometers. I'll put kilometers on the bottom here, and I'm going to convert it to meters. So that kilometers cancels kilometers. And we know that there's 1,000 meters is the same as 1 kilometer. Then we also need to get seconds on the bottom here and cancel out the minutes. So if I have a factor here where there's minutes cancels with minutes, then I'll get meters per second will be the only units left. And I know that there are 60 seconds is the same as 1 minute. So this is equal to 10.0 times 1,000 times 1 divided by, in brackets, 20.0 times 60. So it is good to have a scientific calculator that has parentheses on it. I'm going to go 10 multiplied by 1,000. I'm going to skip multiplying by 1, but then I'll do divided by, open parentheses, 20 times 60. And parenthesis equals 8.333. Let's just use 3 significant digits, 8.33, and it's meters per second. So that is less than 30, but we're saying these are the same. So I think going 1 meter per second is faster than going 1 kilometer per hour. So this sort of makes sense.